Okay, so video starting. Let me just make sure. Here we go. First one. So it says simplify each expression by combining the like terms. So we want to combine the like terms. Let's circle everything that's a 3a. That's a 3a. We have a plus 9a, so I'm circling the plus sign as well. And then I'm not changing colors, but I'm using a square, a rectangle, sorry, with m4. And there's something here that also has m to the fourth power. So if I move things around, I'll get that circle, and I'll move the 9a right next to it. So I get plus 9a. I'm going to move the plus 2m to the fourth power to the third position, and minus m4 stays in the last position. I can combine now like terms. These two a's are similar, and I get 12a. And 2m plus 2m to the fourth power minus m to the fourth power is just 1. Remember, there's a 1 over here. So 2 minus 1 is just plus 1 m to the fourth. Okay? You didn't even need to write that one. Either way, you would have been correct. 2, I can't combine anything right now in this as it is, so I have to get rid of these parentheses, and one way of getting rid of this parentheses is by doing the distributive property. So I'm going to multiply this 5 by every term inside, times this, and that's times that. 5 times 2g, 5 groups of 2g's, I will get 10g. 5 times k, I will have 5k's. Plus 5 times 11g's will give me 55g's. Careful, now it's a minus sign. And 5 times 2k will give me 10k. This last k over here, I'll just copy, including the minus sign. Now I'm going to, let's see, circle everything that's a g. I have a 10g, then I have a plus 55g. The case, I'm going to do, I have a rectangular around the 5k, another over here around the negative 10k, and another one over around the negative k. So the g's together, 10g plus 55g. Let's move the 5k to the third position. The minus 10k comes in fourth, and the minus k will be last. If I combine the g's, 10 plus 55 is 65, and I get 65 g's. I'm going to get a negative number here, so that was my mistake. I made a mistake when setting up the problem, so you're going to get a negative number. So 5k minus 10k is going to be negative 5k, and negative 5k minus k will give you negative 6k. So if you didn't get it, it's okay, because we haven't done addition of integers. So you can even sort of ignore, if you got up to this part right here, you're good. Okay, on the test you won't see any combining like terms where they're negative. Okay. Next one. I don't have to do distributive property, but I can just go ahead and circle the like terms. 32h. Let's see if there's anything else that's an h. That's an h squared. It is not the same, but h is, and so is this plus 6h. Plus 6h. 13k is something completely different, so I'm going to put a square around that. And minus 5h to the second power is something different, so I'm going to put a little triangle around that. So we have 3 different things. So the h's I'm going to put all together next to each other. The 13k I'm going to put here in fourth position, and the minus 5h to the second power I'm going to put in that last position. Please notice that when you move your terms, you also move it with a sign that comes with it. Okay, the sign right before it. 32h minus h. Okay, if you want to put a 1 here, you can. All right, so 32 minus 1 is 31, and then plus 6, you get 37h. There's nothing more to combine, because everything else is different. The variables are different, so just copy, and that's your final answer. Here, again, you see parentheses. Please, you need to do the distributive property before you combine like terms. So 2 times h, you get 2h. 2 times 7m, you get 14m. 2 times that last k gives you 2k. The second group here, I'm going to do, again, a 2 times every term inside. So 2 times 9h's will give me 18h's. Careful with the sign, minus, and 2 times n is 2m. Let's circle. Let's put them in groups. So 2 h's. Is anything else that's an h? Yes, there is. Plus 18h. In a rectangle, I'm going to put the m, so the 14m. Is there anything that's an m? It's something in the back here. And that one goes as a triangle because it's a k. So the h's together, 2h plus 18h plus 14m. And then I'm going to put this negative minus 2m next to it. And I'm going to move the plus 2k all the way to the back. You want to combine the like terms. So 2h and 18h gives me 20h's or 20 something. Something that starts with an h. 14m minus 2m gives me 12m. And lastly, plus 2k. Okay. Let's go to the second part. Simplify each expression using order of operations. Okay. So, what was that? Okay. Let's go. So inside the parentheses, change the number that has an exponent to a standard number. 3 to the second power. It's not 3 times 2. It's 3 times 3. Repeated twice. So 3 times 3 is 9. Then I'm going to raise that to the third power. Minus 35 divided by 7 times 2. Inside the parentheses, 12 minus 9 is 3. And I'm going to take that to the third power. Minus 35 divided by 7 times 2. 3 to the third is 27. Because it's 3 times 3 times 3. Right? So that's going to be 27 minus, I can do something here. Remember, it's whatever you say first or whatever you see first going from left to right. So it's not multiplication, but in this case, division is going to come up first. 35 divided by 7 is 5. And then we'll multiply by 2. Do not do 27 minus 5 because multiplication comes before. So leave the 27 alone. And that's a minus, and 5 times 2 is 10. Excuse me. Okay, sorry about that. And so 27 minus 10, you get 17 over here. Let's do this one at the bottom because it's 6 times 8. We can do 6. Well, let's leave everything like this. Let's do the exponents first, and that's 4 times 4, which is 16. Now, I'm going to do multiplication here because it comes first from left to right. So 6 times 8 is 48. I'll divide that by 3, and then minus 16. Division comes before subtraction, and 48 divided by 3 is 16. And 16 minus 6 will give me a 0. Okay. Let's do this one. I'm going to replace these exponents. So 4 to the third power is 4 times 4 times 4, which is 64. Divided by 2 to the third, which is 2 times 2 times 2, which is 2 times 2 is 4, and then times 2 again is 8. Minus, here I'm going to do, inside the parentheses, I'm going to do 2 times 6 first, which is 12. And the 12 gets added to the 3. And 12 plus 3 is 15. So this is what I have inside my parentheses. And all that to the second power. 64, wow, this is going to be another negative number. What was I thinking? All right, 4 times 4, 16, yeah. 64 divided by 8 is 8, minus, and 15 to the second power is 225. So let's just leave it at that. If you got this far, you should be okay. You did everything right, except that I messed up again, and I left you with something that you haven't learned yet. But if you did, okay, your final answer would have been negative 217. Okay. Okay, the top one. So think of this as two problems, one in the numerator and the other one in the denominator. Just think of it as two different things. Let's take care of the bottom. 7 squared is 49 minus 46, and that's what you have in the denominator. On the top, I'm going to change that. 9 squared, right as an 81, minus, inside the parentheses, 24 24 divided by 2. Division comes before subtraction. So 24 divided by 2, and just let me do that. 24 divided by 2 is 12, and then minus 10. That's going to give me 2. So inside the parentheses, everything is 2. All that raised to the third power. We can continue. 81, we can't subtract yet because I have to take that to the third power, and 81 to the third power is 2 times 2 times 2, which is 8, over 49 minus 46, which is 3. 81 minus 8 is 73 over 3. That's your final answer. If you change that to a mixed number, you can change that to a mixed number. 3 goes in 73 how many times? 20. Why just do this? 3 goes in 7 once. No, twice, which is 6. 13 goes in 24 times. Okay. And you have 1 left over 3. So if you change that to a mixed number, it's 24 and 1/3. Ugly problem. Sorry. So these two, definitely. I guess I wasn't paying attention. Sorry. Let's go down to the next questions. Translate each sentence to an algebraic expression. I think it's easier if you always just do it, right there. 1/2, that equals to this, and literally translate bit by bit as you go along through the sentence. Of its times a number we don't know, so pick a variable, pick a letter, and let's just there 1/2 of n. So if you want to clean it up, there, that's what it will look like. Next one, 6 times the difference of y and 3. So 6 looks like this, times looks like this. The difference, you're going to multiply 6 by the subtraction of these two. So let's protect that. As a parentheses, y minus 3. That's what difference means, subtraction. So I have to subtract first and then multiply by 6. Okay, so you need that parentheses. Okay. Next. 11. 7 again. If you do it slowly and just write it, 7 means 7, of course. Less than means subtraction. 3 is 3. Times is your multiplication. And a number, let's just pick a. That's what it looks like. You have to be careful because this is a turnaround word. And so we're going to switch places here. 3a is going to go here. And minus 7. So that's what 7 less than 3 times the number looks like. 12. Quotient. Quotient is division. We're going to use a fraction to represent that. But what are we dividing? A number. So whatever comes first goes in the numerator. And let's pick k, just because we can. So the quotient of a number, k, or a number k that we don't know, represented by k, and 5. Increase by 4. Increase is addition by 4. Okay. Let me go to the next. Here is, and it's been a while since we've been doing these words things, right? The words for your test. So this is what's playing in the background. The Cure. And the name of the song is, oh my god, so Magneto. Disintegration. No. Sorry, that's not what I'm saying. Fascination. There you go. That's the name of the song. Fascination Street. It's been a while. Okay, that's the name of the song. So this and this will get you 5 points. Well, obviously, it's everything else. So let's substitute. It's 3 times a to the second power, which is 3. And b is 2, so that's times 2. Oops. And then minus c, and c in this case is 4. Okay, so remember when you're replacing these variables with values, okay, if they're next to other numbers or next to other variables, you have to be multiplying them. Okay, don't multiply yet because you have to get rid of this exponent here. So let's just change that. 3 times 3 to the second power is 9 times 2 minus 4. Now you're ready to multiply. Okay. 3 times 9 is 27, and 27 times 2 is 54. Minus that 4 gives you a final answer of 50. ABB minus A8, so let's substitute. A is 3 times b, which is 2, times another b, which is another 2, minus AA. AA is 3 times 3. Let's multiply. 3 times 2 is 6. 6 times 2 is 12. Minus 3 times 3, which is 9. And final answer is 3. Over here, 3 times b, and b is 2. Plus 3 times a, and a is 3. All that over b, which is 2. So on top, 3 times 2 is 6. Plus 3 times 3 is another 9 over 2. And 6 plus 9 is 15 over 2. And 15 over 2 is just 7.5. Okay. 15, a squared plus b squared plus c squared. A squared is 3 to the second power. B squared is 2 to the second power. And c squared is 4 to the second power. 3 to the second power is 9. 2 to the second power is 4. And 4 to the second power is 4 times 4, which is 16. I can now add all those, and that gives me 29. 16. The formula to change Fahrenheit to Celsius is C equals 5 over 9, parentheses, Fahrenheit minus 32. Find the temperature in Celsius if the temperature is 86. So if it's 86 degrees Fahrenheit here in the United States, what would the rest of the world think the temperature is? So that's what we're doing, okay? Because as far as they're concerned, we're probably boiling. 5 over 9, and instead of the F, we're going to replace it with the 86 minus 32. Okay, so temperature in Celsius is, let's see, I can subtract 86 and 32, which is going to give me 54. So it's 5 over 9 times 54. To continue this, I have a fraction, a whole number. You can put this as a fraction over 1. Top was top, bottom was bottom. So 9 times 1, the bottom is 9. And 54 times 5 is, let's see, 5 times 4 is 20, goes to 27, 270. And 270 divided by 9 is just 30. So in Celsius, 86 degrees is 30 degrees. Okay, so now they would understand what temperature or how hot or cold we would be at. The length of a rectangle is 4 less. So again, so here you can write the length of the rectangle is, the length is equal to what? 4. Here's your 4. Less than, minus 2 times the what? The width. So what is the length of the desk? Well, the length is this. But because it's turnaround word, we're not going to leave it like that. We're actually going to do 2w minus 4. So the length of the desk is 2w minus 4. Identifying the number of terms and all that stuff. Okay. So terms are how many parts or how many pieces. Think about the number of pieces this expression is made of. For us, addition signs and subtraction signs serves as commas. So in this particular case, we can think of this expression as 4k, comma y, meaning there's 2 terms, which are 4k and y. My coefficients, I have 2 coefficients, which is the number in front of the variable. One of them is 4, and the other number in front of the variable y is a 1. It's hidden, invisible, but still there. Do I have any variables? I have, yes, 2 variables, and they are k and y. And I have no constants, so I'm not even writing that. On this side, how many terms do I have? I can say I have 3 terms. This expression is 3 parts long. 4m3, comma 3r, comma 13. So there are 3 pieces, 3 terms. Coefficients, there are 2 coefficients. There are 2 numbers next to the variables, and these are the 4 and the 3. Not 4m to the 3rd power, not 3r. The coefficient is just a number next to the variable. Okay. Variables, I have 1, 2, two variables, 2 letters representing an unknown. And the variables are M and R. And do I have any constants? Any numbers standing alone? Yes, I have one constant, one number all by itself, 13. Okay. Tammy has saved $85 in her piggy bank. She's planning to save $35 each week. Write an expression to represent the amount of money she will have after W weeks. Then use your expression to calculate how much money she will have after 7 weeks. So let's write what she has. Okay. For sure, she has $85. That's how much she has. And she's going to add $35 every week. So $85 plus $35 that she's going to put every or per, you're going to multiply that per the number of weeks. Right? So after week 1, how much money will she have? Well, it's 35 times 1 week, which is 35, and then plus 85. After 20 weeks, what it would be? Well, after 20 weeks, it would be 35 times 20, and then add it to 85. So let's see how much money she has after 7 weeks. After 7 weeks, you would use this expression. So 85 plus 35 times 7, because that's, remember, every week she's putting $35 into her piggy bank and $35 in piggy bank, etc. So after 7 weeks, she has some money. So she had the original 85 that maybe her grandpa or someone gave it to her to start her savings fund here. So 85 stands alone for a little bit, and then we're going to have to multiply 35 times 7. And that's 35 goes 3, 7 times 3 is 21, plus 3 is 24. So after 7 weeks, she's going to have $245 that she put in on a weekly basis, plus now we're going to add the 85 that she started with. So 245 plus 85, 10, 1, 8, 4, 13. Goes 1, 3. So at the end of 7 weeks, she's going to have this much saved. Pretty good amount. And, well, the last two, this was simple. Use a property to create an equivalent expression. So here, I can create a different expression, and I will create 9 plus 8. And what property did I use? I used the community property. Community property says that if I change the order in which these two numbers are added, I get the same. So 8 plus 9 and 9 plus 8 are equivalent expressions. Okay. Here, what property can I use to generate an equivalent expression? I can use the associative property. So using the associative property, I can do something like this. This says A times B first. Please take A times B first and then multiply by C. That's what this says. But with associative property, it tells me that if I do this, it's not going to really matter, because I'll still get the same answer. I can multiply B and C first and then by A, and I can still get the same answer. Okay? There is another expression I can do here. I can use the commutative property. The commutative property, remember, says this: 3 times 5, and if we switch that around to 5 times 3, I get the same answer. So I'm going to do the exact same thing here. So I'm going to switch around. So look at this, going back to this, so I'm going to switch the A and B. That's going to go to the back, right? And I'm going to bring the C to the front and switch places. Right? Just like I switched the 3 and 5 to 5 and 3, I'm going to switch the A and B, which is considered one item, and I'll put that in the back and then move the C to the front. Did I change anything? No, I just created a new expression using the commutative property. So here I have 1 and my second expression. Okay? Hopefully that helps you guys. And that's it.